Hey everyone, welcome to 6.5 example A. Here we go, and 6.5 is all about solving systems of inequalities, not just equations but inequalities, which means we have to shade, make sure we have dashed or solid lines and that kind of stuff. So we're going to go right into this problem. We'll kind of show you as we go. So it says Rachel has 3 hours to work on homework tonight. She wants to spend more time working on math than on chemistry, and she must spend at least a half hour working on chemistry. Here's what we're going to have to answer. Let x represent time in hours spent on math, y is the time spent on chemistry. Write inequalities to represent these constraints of the system. Then graph it and shade, and then find the coordinates of the vertices of the feasible region. Then name 2 points that are solutions and say what they mean. Alright, so what we will do first is I know that x plus y, math plus chemistry, has to be 3 hours or less. So it can be less than or equal to 3. Alright, there's our first equation. The next one, she wants to spend more time working on math than on chemistry. So x has to be greater than y. Not equal to, it's got to be more time. And then the last one, she has to spend at least a half hour working on chemistry. So y has to be greater than or equal to 1/2 of an hour. So instead of writing 30, I'm going to write a half. So if I want to graph these on a graphing calculator or something like that, what I want to do is get the y all by itself. So I'm going to subtract x. I'm going to say y is less than or equal to negative x plus 3. I'm going to just switch these around. Y is less than x, and this one is y is greater than or equal to 0.5. Okay, so now what we should do is we should go right to our, right here, and I'm going to move me a little bit so that way we can see what's going on. So our first equation is going to be y is less than negative x plus 3. So there it is. I don't have the less than or equal to signs. We'll take care of that in a minute. The next one is y is less than or equal to just x. And the last one is y is equal to 0.5. So I'm going to do 0.5 plus 0x, so that way it'll show up. And there are my 3 graphs. Okay, now I am going to just get rid of this, move this over here, and I'm just going to take a screenshot of this, and we are going to get our graph somewhere where we can shade it. So here's our graph, and we are going to shade the feasible regions. And I'll move myself back here. I like that a lot. Alright, so we have the first equation that we have, let's go here, is going to be y is less than or equal to x, negative x plus 3. Less than or equal to. If I think less than or equal to, it's going to be shaded below. And this line is going to be solid. Alright, so it's going to be below and solid. So what I'm going to do is that's this one right here, the red one. So I am going to shade with red below. So it's going to be down here. Alright, in that region. We don't have to shade it really well. And I'm just going to make it a little bit lighter here. Well, let's go here. Let's grab this one, make it lighter. Okay, that way we can say it's there, but it's not going to interfere with everything else. Now let's go to the next one. Y is less than x. If it's less than, it's going to be below, and it's going to be a dashed line. Okay, it's going to be dashed because it's not equal to. So the y equals x is going to be that blue one. Let's pick blue, and it's going to also be below, and this blue should be dashed. So I'm going to shade it down here. All right, so this blue should be dashed. Let's just make some dash marks on it. We don't have to be too concerned about it because I'm sure that you could do it by hand a little bit better than I am. Alright, and now we have the last one. It's y is greater than or equal to 0.5. So it's going to be shaded above, and it's going to be solid. So we don't do anything with changing the line, and we're going to shade above with green. So there's green. And I'm going to shade above this green one. Alright, so now where is all these shades? Where are they? It's below the red, so it's going to be on this side of the red. It's below the blue, which is on this side of the blue, and it's above the green. So where that is, I'm actually going to erase the stuff where it's not true, and it's going to be none of this, and none of this. It's got to be where the red, blue, and green all intersect. So our intersection is really in this little triangle region right there. All right, so there is the graph. So we did part A, made our graphs. Part B, we graphed it using this stuff. Part C, says find the coordinates of the vertices. So what we can do is we can go right back to here, and with Desmos, which is really kind of handy, I can just click on those and it'll tell me the points. You could also do the same if you were to graph it. Here are those points that are the coordinates of the vertices of the feasible region, where it's bounded by, because remember we said it's inside this little triangle. So these are the vertices of our triangle. Now remember, this blue one is a dashed line, so these are not actual solutions, right? This is not a solution, this one's not a solution, because the point on the line is not a solution if it's just a less than or greater than. All right, so part D. It says name two points that are solutions to the system to describe what they mean in the context of the problem. We can take any points that are in here. So if I just remove this, if I say the point 1 and 1 or 0.75, if I do 1, 0.75, oops, there we go. 1.75 is one solution, and let's get another one. You know what's another one would be? This red is solid, this green is solid. 2.5, 0.5. 2.5, 0.5 is another solution. There are 2 points. What do they mean? That means, remember that X is math, Y is chemistry, so it means they spend 1 hour on math. They could spend 0.75 hours on chemistry. Right? It could be more than that, it could be less than that, but it's at least, she's done at least a half hour, and it's less than math. Same thing here. 2.5 is 2.5 hours on math and 0.5 hours on chem. Which I think, if we go back to, let's make sure it meets our constraints. She has 3 hours. That's a total of 3 hours together. She spends more time on math, 2.5 versus 0.5. That works. And she must spend at least a half hour on chemistry, 0.5. That works. So those points just mean X is how much time she spends on math, Y is how much she spends on chemistry. All right. There you go. There's example part A.